Now that you've learned some of the basics of Java, we want to be able to add another layer to it, and we're going to learn to use decisions today. So a decision is a structure that allows Java to choose what part of your code to. So I'll make a new project called Decisions. And I'll show you how we can do a basic program here. So we're going to do the absolute value of a number, and it is possible to do the absolute value with the math class, but I want to do this to illustrate how an if statement works. So we're going to use the scanner class here, java.utilities.scanner, and we'll create a new scanner so we can get some input from the user. Oops, missed an N in there. So what I want to be able to do is print a message that says what the absolute value of their number will be. So please enter a value. And maybe I'll print line. So int value equals keyboard dot next int. Okay, so I've read in the value from the user now, and what I want to be able to do is say, this is the final statement I want to be able to say is the absolute value is, and then be able to tell them that. So why don't we create a new variable, I'll call it absolute value, and we'll start just assume that it was the one they gave us. So what we have to do is we have to check, because for absolute value, if it's negative, that means I'm going to remove the negative sign, and if it's positive, I'm going to do nothing. So I'm going to say if the value is less than 0, and I have to start a block. What Java's going to do when it gets here in my code is it's going to evaluate whatever's inside these brackets to see if it's true or false. Now, anytime you have an if statement, it'll be the same thing. You'll say if, you give it a condition here, it must evaluate to true or false. If it's true, it will go immediately inside the block we've just defined. So between these braces, all of the code I type in will be executed. However, if it's false, it will skip this block entirely, and it will just go right to the next part of the program, which is here. So what I'm going to do then is I'm going to say if it was less than 0, then the absolute value is equal to -1 times the value they gave me. So if I run this, and I enter in the value -10, it says the absolute value is 10. What Java did was it read in 10 here, then it said 10 was less than 0, so the absolute value is -1 times -10, which is +10, and then it went and printed out +10. Java can ignore it if it's something like 5, because Java would go here. After it's read it in, the value 5 is not less than 0, so it will go immediately down to this thing and just say the absolute value is 5, because that's what I've already set it up to be equal to the one they gave me. So basically the only time this interferes is if I have a negative number, and it will times that negative by a negative in order to make it positive. Okay, so let's just take a look then at the if statement. So here's the syntax that you'll be seeing whenever you use an if statement. It always starts this way: if you give it a condition and your programming statements follow inside of a block. Notice that the style here does matter because the braces are lined up and the code is indented. I will be checking this to see that you follow the same protocol. You will notice too that other programmers across the world would do something very similar. There is a slight alteration that some people make, and it is fine. I'll show you what one alternative is some people do this with their block, is they start it here and leave the other brace lined up. I still prefer, and I'll expect to see this in our class, that you leave them lined up vertically. It's easier to find them when they're missing, when they're in this format, than the one I just showed you. So you may see either of those, but it'd be pretty rare to see something different outside of in another programmer's code. So this is the convention we will follow. Please line them up vertically when you use your braces. The operators that we use for if statements, we just mentioned we had a less than sign for less than 0 and when we just ran our program. And these are the ones that you'll use in Java for doing comparisons against numbers. And the equals you have to be careful with because it's a double equals here. It's not a single equals like the one you use for assignment. Not equal, this exclamation mark is used for not. So this means not equals. Less than or equal, greater than, and greater than or equal to. So that's a common mistake. Be careful about that. Single equals is not the same thing as double equals. You'll get the hang of it real quick, but just keep it in mind when you start your first programs. So we'll try a program now that's a little more reasonable as far as practical and being useful goes. Let's say please enter your age. And we're going to say that you get a senior's discount. So within keeping good style, let's say a senior is 65. And this isn't a value since I'm using age. That's what I'm going to change it to as age. Okay. And let's just say that rather than, we'll start this new here, if they are over greater than or equal to a senior, I'll apply a discount. So double cost equals maybe $10.50. And if the age is greater than or equal to a senior, then I will apply a discount. So maybe I'll tell them, you qualify for a 10% discount. And maybe I'll tell them how much that is. So double discount rate is 0.1, so 10%. So I'll say you qualify for a 10% discount, which is cost times the discount rate. And then I will tell them that their cost is equal to, and I'll apply that 10% discount. So they lose 10%, so it would be what the cost was before, take away that discount, which is cost times the discount rate. Now there's several ways we could rewrite this. I'll just show you. We could either go this way, we could go and factor out the cost, so 1 minus the discount rate times the cost. It would also be equivalent if we did a shortcut operator. Cost minus equals cost times the discount rate. So just to jog your memory on a few different ways we could do it, but I will leave it in the first one that we had to do our program. So I'll put a message now to tell them for someone who is, and I'll put age so this way they'll be able to see what's happening. Okay, so let's just say the age of the person is 45. For someone who's 45, the cost is $10.50. If I run it again, this time I'll make them 80 years old. You qualify for a 10% discount, which is $1.05. For someone who's 80 years old, the cost is $9.45. So you see now Java knows when to apply the discount and when to not apply the discount. And it does that with the if statement. Now if I wanted to give a message that said something like, that told the other person that they don't get a discount. There's no discount unless you are a senior. Maybe we'll just say unless you are over senior years old. Now the problem with this is if I run it, it seems to work great if I go 40. There's no discount unless you're over 65. For someone who's 40, the cost is $10.50. Great. But then if I'm 80, like it was before, you qualify for the discount, and it still says there's no discount unless you're 65, over 65 years old, which seems really strange. It did apply the discount, so we shouldn't write that part of it out. We should have that out of the code. So how do we tell Java that we don't want it to do this part? So again, it's going to be a decision that Java makes, and the easiest way to do it is to use an else block. So what can follow an if statement? If you have an if statement like this, if it's false, it will immediately go to the else block. So if this is true, it will immediately go here. Otherwise, it will go to the else block. So an else block, it doesn't have to be there, but when it is, that's its purpose. So exactly one of these two will be executed by Java. So if it's true that they are a senior, it will go into this block, and it will not do anything else in this code except go right to the end of the if-else statement right here. If they're not a senior, it will not go into this block, and it means it immediately goes to the final block here. So this time when I run the program, if they're a senior, you qualify for someone who's 80 years old, the cost is $9.45. So that's showing you that this time, because they are a senior, it does not execute this code here. This code is only executed if this was not true. So what I know here is that age is less than 65 in order to get inside of this else block. So why don't we try one more else statement. So I'm going to start with a different program. Relatively simple again, just getting some keyboard input. So please enter a value that is divisible by 5. Then here I'll go if, sorry, I need to get the value first. Okay, now that I have the value, I'm going to test that. Now, when something's divisible, the remainder is 0. So I can check to see if it's divisible by saying, is the remainder when I divide by 5 equal to 0? If it is, then I'll say you are correct. And maybe I'll even say what they did. So I'll say value is divisible by 5. Now, if that was not true and the remainder was not 0, I'm going to say else. I know they were incorrect, so I only want it to go to this block. I don't want to tell them they're correct and then incorrect. I only want one of these two blocks to be executed. That's how I know it makes sense to use an if-else. Only one of these is going to be used by Java because they either were divisible by 5 or were not. So let's say, sorry, you'll have to try again. Value is not divisible by 5. So let's run the program and we can talk through it and see what happens. Let's enter 25. You are correct, 25 is divisible by 5. So it checks, the remainder is 0. When the remainder is 0, I know it's divisible. So that means I'll print out it's divisible by 5. This time I'll try 23. Sorry, you'll have to try again. 23 is not divisible by 5. So it tried this, and the remainder was not equal to 0. So because this is false, it goes to the else block, and it only executed this code here. The first block was skipped. So this block would happen when it's true, and then it goes here if it's false, but only one of the two will be, they're like a pair. You can think of them together. They're stuck together. They can't be split up. In fact, they can't be split up, and you can't do even something like this. Because if you're putting code in the middle, Java can't find an if statement, see it says else without an if, to put it with. So you can't even put code between them. They are in fact needing to happen one right after another so that Java knows they came together. Okay, so let's just take one quick look here. The syntax for an if-else in Java, just so you can recap it. If, and you have a condition, just like we did before. So this is the if statement, and then it must be, if you're going to use an else, it must be connected directly with an if. and any programming statements that if it's false, it goes immediately here. So we're going to take a look at one more way that we can do decisions, and this is, beyond this, everything else we're doing is just some extra technique, but that's to chain them together in another way called an if, else block. So all I'm going to do to show you how we could answer this question is, let's try and do grades. So we're going to assume that you have a letter grade, and will you give me a percentage and I'll give you the grades. So I'm going to start again fresh, and I'll get rid of this block that we just created. And I'll say, please enter your percentage. Now, a percentage could come in as a double, so that's what we're going to change here. And I should give this a better name, so I'll call it percent. So I could do something like if percent is greater than or equal to 86, then I could say, I should say percent. Then system.out.println, your grade is an A. But how would I keep doing the rest of the letter grades? Let's just see what happens if we break them up. So if they're over 73, then you have a B. The next one's at 67, where you get a C+. Then at 60, where you get a C. And then at 50, where you have a C-. And, oops. And if you're less than 50, you get an I. I guess I should call that AB. Okay, so if I run the program, 30%. Oh, awesome. It seems to be working because it says the grade is an I. But what if I was to pick something like, I don't know, let's try 90%. Oh, didn't make a right decision because it says A, B, C++, C, and C-. Because remember, what Java's done is said, is 90% greater than or equal to 86? That's true, so it goes to this code. It will then check the next one and say, is 90 greater than or equal to 73? That's also true, so it says you've got a B. Is it greater than or equal to 67? That's also true, so it keeps going through. And the only one it's not true for is not less than 50. So that's why it didn't pop up as an I. So clearly we need another way of making Java decide on our code. And there's a real easy fix, and it's called the else if block. So by making this an else if, the difference is it works just like we did with an if else statement. Only one of these is going to be executed. So when I go like this, what's going to happen is if this is true, it'll immediately execute this code, and it only goes here if it's false. That's what else does. As soon as it's false, it goes to the else block. So the only way that I even check to see that the percent is greater than or equal to 73 is that it first had to be less than 86 in order to make this one false. So what happens is Java checks this one. If it's false, it'll go here immediately. If that's false, it goes here. If this one was true, it would stop, and it would go right into the block, and it would not look at anyone else because it only goes in to where that statement's true. All these else would require it to be false to keep going. So they're chained together that way. So if we run it now, and I put in the percentage, like let's say 80, I should just get a B from this. Your grade is a B, so it worked. There's also one other thing we can fix about this program, and it kind of finishes off the way the decisions work in Java, and that's as I go through the structure, what I'm going to see as I get here is that this bottom one, I've gone through all other possibilities. So if I was not greater than or equal to 86, greater than or equal to 73, greater than or equal to 67, all the way down, and greater than or equal to 50, I have to be less than 50 in order to get past all those ones previous to me. So it makes sense to just call this an else. And that's how it gets its name, if, else block. So they're all chained together. These in Java act like one group. the way you can tell again that it's part of one group is they're chained by else's. It goes if, else if, else if, else if, else if, else. They're all connected together. It's not required that you have this else here, but the else is what chains them all together. You'll get the same error if you try and put something in the middle, because Java is going to say, these things are, say else if without an if. See, same error we had before. So what's the advantage to doing it this way, aside from the fact that this program works correctly? If I run it now, I should get any letter grade I want. Like maybe I've got 76.5%. It's a B. It'll still work if I have 38%. It's an I. The other advantage is efficiency. Because Java only checks these conditions until one of them is true, it's much faster. Because, for example, if I have an A, this would be true. It would not bother to check any of the other ones. So that would save the computer 1, 2, 3, 4, 5 different decisions it would have to make. And these are where it really slows down the program. So even if I had a C+, I still save 1, 2, 3 possible statements here that I would not need to evaluate anymore. Once I know the letter grade, I don't need to keep looking. So if I was to make this just if statements like this, Java will check every if statement that's not chained by an if-else. These are independent in Java. Notice that I can put stuff in the middle and Java won't complain about it because Java treats them all as a separate block, separate if statement. So there's no problem with doing this. I haven't put it in between anybody. It only complains if they're chained together like this. So it's not only faster and makes my program run better, it's also, it gives us the structure here that makes this program correct. Okay, so here's the if-else syntax again, just to recap. So if you have a set of statements where you want exactly one of them to be triggered, then you would chain them all together with the else. So if, else if, else if, all the way down until you hit your last else statement, and exactly one of these will be executed by Java. If all of the ones here were false, then the last one here would be executed in the else block. So exactly one of these will be executed. It's also possible, as I said, you don't have to have that else statement in there. This bottom else statement could be removed, but it means that if all of them were false, then nothing would be executed in these blocks. And you may want that behavior in your program. So if you're using conditions on, another sort of trick for you is if you're using conditions on the same variable inside the brackets, generally you don't need to ask the same question to Java more than once. So if you're, say this was age greater than 10, age greater than 20, age greater, if it's all on the same variable, it's usually that you want to chain it as if, else if, because like I said, it's the same variable, you're asking Java a question about the same thing, so usually you don't want to start over with a brand new if and say if age greater than 10, if age greater than 20. You would chain them together with an else. So I'll do one more program with the if-else if block, and what I'm going to do for you is we'll do the Richter scale here. I think there's an H in Richter. Anyways. And then we'll make some comments about what the, how intense the earthquake was. So if the Richter scale is greater than or equal to, let's say 8, system.out.println, let's say run for the hills. That's a pretty bad earthquake. I hope that there's none that bad. Now, otherwise, we could say everything's going to be okay. Just duck and cover. Okay, so it's not a very descriptive program here. If I if I give it a reading like 10, run for the hills, but you know, a 7's still a pretty bad earthquake, and it says everything's going to be okay, just duck and cover. So I don't want to give the description of the earthquake more than once, right? Because if I go if Richter is greater than or equal to, say this time I'm going to go 6, maybe I'm going to give a less severe message and say something like duck under a table and count to 60. Help is on the way. Okay, so this time, remember the problem is if I have an earthquake that's something like 10, I get both messages because it does that decision twice. It's asking a question on that variable 2 times here. There's no chain. These if statements are both separate. So because I'm asking a question about the same thing, I'm usually going to chain it together with an else statement so that I only get one answer back from all of them. Okay, so this time if I was to do the same thing and put in, say, 10, I only get the one that says run for the hills. And that's the behavior that I wanted. If I had something like 5, then everything's going to be okay, just duck and cover. And, you know, for example, if I had, say, 6.5, well, 6.8, duck under a table and count to 60, help is on the way. So it's not super severe, but, you know, you should definitely be doing what your training has for earthquake readiness. So that should give you an introduction to using the if-else structures and the exercises that are attached. Hopefully this gives you enough background to get going.